How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss how to describe the graphs of a linear equation in terms of 2 points, slopes, and its intercept. So, before anything else, hit the subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for Quarter 1, Week 6 of the Grade 8 Mathematics, which is all about how to describe linear equations using 2 points, the intercepts, the slope and the y-intercept, the equation, and others. Okay, now, describing the graph of a linear equation is very easy. Why? Because all the graph of linear equations are aligned, right? Because that is why it is called linear equation, because when you graph the linear equations, it will always form a line in the Cartesian plane. But there are 4 descriptions for the graph of your linear equation. The first is increasing, when it starts from the bottom, then it goes up. The second is decreasing, meaning it started above and then it goes down. The second one is horizontal, meaning it did not rise, it did not fall. And we also have the vertical. It's just parallel to your y-axis. So, how do we know whether those are the given? Okay, now let us consider our first example. We have here negative 3, 0, and 0, negative 3. These are 2 ordered pairs, right? But remember, the given pairs has 0 as the coordinates. This 0 simplifies an intercept. Remember in our previous video, if your y coordinate is 0, then you get your x-intercept. If your x-coordinate is 0, then you get your y-intercept. So basically, negative 3, 0, and 0, negative 3 are x and y-intercepts of this given condition. Okay, so where is that? We have negative 3 for x, 1, 2, 3, that is here. We have negative 3 for y, 1, 2, 3, that is also here. Now, if you connect them, you will have this graph. And as you can see in this graph, this is decreasing. Okay? So that is how you describe this linear equation. Easy, right? Now, let us go to our second example. We have positive 2 for our slope, and our y-intercept is also positive 2. Remember that the slope is the rise over run. Okay? So the slope is your rise over run. If you have positive 2, remember that all whole numbers has an invincible over 1. It means that you will go up 2 times, 2 units, and then you will run 1 unit to the right. Okay? So, how do we graph this one? Basically, you start with your y-intercept, that is positive 2. So, let's just continue our graph here. So, this is the graph of, this is 0, negative 3, while this is negative 3, 0 for our first example. Now, for our second example, we have, so we start with our y-intercept, that is positive 2, so that is located here, 1, 2, so that is here. And then we will use our slope. We go up twice and we run once. So we go up twice and then we run once, so that is here. Okay. So basically, if you connect this dot, so you will have a graph like this. So as you can see, this is increasing. It started from the bottom, then goes up. Okay? So, as you can see, if this 2 is available, or if this 2 is extended, this 2 graph, this is extended here, going here, and this is also extended going here, basically, they will also intersect. But that's not the point in our discussion today, because what we are discussing here is how do we describe the graph given this kind of scenarios. Okay? So for the first one, we have decreasing, and for the second one, we have an increasing graph. Easy, right? Now let us go to our third example. We have f of x is equal to negative 5x minus 2. Now, some of you might be wondering, what does f of x means? The f of x means function of x. Basically, in the previous discussion or in the previous years of mathematics, f of x is also known as the y variable. Okay? So, basically, this is just mean y is equal to negative 5x minus 2. So, this is a given in a slope-intercept form. So, therefore, you have your slope. This is the one that is negative 5. And you have your y-intercept as negative 2. So, what does this mean? Your y-intercept is located here. So, negative 2. That is here. Okay? And your slope is negative 5. Remember that if it is a whole number or if it is an integer, there is an over 1 that is hidden. Okay, so that means we go down 5 units and then we run 1 unit to the right. Okay, so from here, we go down 5 units. 1, 2, 3, 4, 5. Okay, and then we run 1 unit. We have here. Okay, so our next point is located here. So if you connect this one, so this is your graph for the third given example. You have your y-intercept, and by the use of your slope, you have a second point or second ordered pair in this location. Okay? So, I hope you don't get confused on our graph here. Okay? And now let us go to our final example. We have positive 1, 1, and 2, 1. So, where is that located? This is an example of 2 points. So, 1, 1, that is located here. And our positive 2, 1 is also located here. Positive 2, 1, 2, 1. So, that is also here. So, as you can see, that is a horizontal line. And this is basically parallel to your x-axis. Now, what does this mean? It means that for its rise over run, the rise did not happen. Okay? So, that means that is 0. And then your run, that is 1. So, basically, your m here is equal to 0. So, how do you describe this one? Just remember these facts. When your slope is positive, so as you can see here, we have a positive slope here, right? Okay, 2, 1. So this is our positive slope. When your slope is positive, the graph is increasing. When your slope is negative, this is a slope that is negative. Therefore, the graph is decreasing. Now, if your slope is 0, your graph is along the horizon, or meaning it is horizontal. But if your slope is undefined, okay, how does undefined mean? Undefined means that your run is 0. So basically, if your rise is 2 or 1 or any number except 0, and your run is 0, then that means that the whole value is undefined. And your graph will become like this. Okay? It will become like this. Vertical line. That is parallel to your y-axis. And this is how you describe graphs of a linear equation given different scenarios. And I hope that is very clear to you, my dear math learners. And now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time learning how to describe the graph of linear equations. If you do have some questions, do not hesitate to write in our comment section below. This is still your free access math teacher Ash, and always remember, it is fun to learn mathematics if we are together learning. Thank you to all our subscribers to your support by sharing and putting a like in our videos. I hope we can reach out as many students as we can, especially in this whole pandemic. Take care, God bless, and always keep safe. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.